Welcome, this is the 3.3 Ready Set Go Homework Solutions. Here it asks us to fill in the tables of values for each of the linear functions and circle the point of intersection of the two lines in each of the table. Alright, so very straightforward. Okay, here's your original equation. Alright, once we found the original equation, we have to plug in the different values. So we're going to try to find 0, 1, 2, 3, and 4, and 5. So let's do the first one. I let x equals to 0. Plug that in. I got f of x equals to negative 5. Right? I do that with 1 as well. I got negative 2. Plug that with 4. Let x equals to 2 now. Let x equals to 3. Let x equals to 4. Pause it if you would like to see the work. Alright, just simple multiplication and then subtract by 5. Okay, once I did that, I got the chart. There you go. Okay, alright, good. The second one was the g of x part. I did that as well. Okay, it looks like these two don't intersect. Okay, right. So how can we tell? Right, let's just put in the decimals. Makes our life easier. Subtract 5. That was the first one. It's 3x minus 5, and the other one was x plus 1. Does that intersect? Yep, it intersects at 3, 4. Right? There you go. 3, 4. 3, 4 was its intersection. There you go. That's how you do it. Alright, plug into decimals. I didn't see it when I looked at the chart, but once you plug into decimals, your life was made easier again. Alright, so again, you have to do these algebra steps to figure out the chart. Okay. Then you could apply it or just plug in the other values to fill in the rest of the chart. Then compare it using decimals. Okay. Or just look at the chart. Alright. It's whatever values they share the same. Alright. This one looks like, let's see, 3 and 6. No. 4 and 8. No. 0 and 0. 1 and 2. No. These looks like they do not intersect. Alright. Let's see if decimals can help us out here. X here plus 2, and the other one was 2x. Yep, there is a 2, 4. This was 0. 1 was 1 should have been 3. 2 would have been 4. 3 should have been 5. This should have been 6. Yep, that was the error because the intersection was at 2, 4. There you go. 2, 4. Good. The next one, let's see if any of them looks 2, 2. No. 1, 4. No. 0, 6. No. I might have done something wrong here as 2. Let's just look at this one. Decimals help us out. Here's 3x minus 4 and negative 2x plus 6. There's an intersection at 2, 2. This one is correct. They say this one's wrong. So if I plug in 0 here, I got negative 4. If I plug in 1 here, I got 1 would be 3, minus 4 would be minus 1. So the common ratio here is plus 3. So that should have been a 2. That should have been a 5. And that should have been a 5, 6, 7, 8, 8. Alright. Yep. So they should have that common difference of 2, 2. Next one. Hopefully I didn't make an error in this one. Oh, I think I screwed up this one too. Alright, let's see. 4x minus 9. Did I get those points right? And the other one was 2x plus 1. Yep, there was an intersection. At 511, ha ha ha. They tricked you here. I didn't make the chart far enough, but there is an intersection at 5, 11. Okay, there you go. So just continue your chart. You're going to see its intersection at 5. It was at x equals to 5. The y was 11. Alright. Good? Alright, so let's just look at the other ones here. Okay. Now we're gonna do the set part. Alright. Determine if the statement is true or false. If false, please explain. Alright, all linear functions are increasing. I'm gonna show you. False. This is the one with the negative slope, negative x plus 4. Okay, I proved it wrong. Alright, next one. Arithmetic sequence or example of linear function. This is somewhat true. Arithmetic sequence is actually a subset of all linear functions, so you could say that they are an example, right? It's just sequences have finite domains, so and functions, linear functions, contains all real numbers. 7. Exponential function have a domain that includes all real numbers. This is true. You can't plug in anything in here for x that would break this equation, okay? Except imaginary numbers. That's why they say all real numbers here. 8. Geometric sequence has a domain that includes all integers. Again, this is wrong. Sequences do not contain all integers. Right? Let me show you one. 3, 9, 27 is a geometric sequence, and it doesn't contain 4, 5, or 6, or 8. Okay? 9. The range for an exponential function includes all real numbers. So I graphed it. 3x. That is false. Does not contain all real numbers because negative 1 was missing. Negative 2 is missing. Okay? You can't say all real numbers, but you could say all all whole numbers because in this case 0 was included. Right? But you can't say real numbers though. 10. All linear functions are all linear relationships or functions with a domain and range containing all real numbers. That is true. Alright, let's go to the go part here. Okay. For its graph, state the domain and of the function using interval notation. Okay. Okay, that's the answer. Okay. Just let it review the domain here. Do you want to see this in Paint? I could bring it up in Paint to show it to us. Give me a second. Alright. Here. Alright. So let's look at the domain. Let's make that red. Alright, the domain refers to your x values. So it looks like it goes from here at negative 4 all the way here to 0. Then there's a gap here. Goes from here, which is 1, here, which is 3, then here, which was 4, then here was 5. Okay. What about your range? Your range starts from the bottom, which is negative 4, goes all the way up here to 2. Alright, there you go. Alright, here's the next one. Right, I would say the domain here is negative infinity to positive infinity. The range is the same thing. Right, that's a straight line. Okay, linear line. Next, the domain here was negative infinity because it starts here at negative infinity, goes up, and it almost hits 3. It's open at 3. That's why it's open here at 3. It's open at 3. It does not include 3. Next one, 14. Here it's open at 1. That's why the domain in 1 goes all the way there to positive infinity. For the range, it starts our smallest value 0, goes all the way up to 1, but it's open at 1, does not include 1, right? There you go, that is 14, that is your answer. Alright, there you go. Those are all your homework solution for the 3.3.